project for week 5 of Head Starter. It's AI Rate My Professor. It was built in a group of 4, an innovative platform for evaluating educators using AI. So for the introduction, AI Rate My Professor revolutionizes how students access their educators by leveraging advanced technologies to provide insightful evaluation. The platform was built on NextJS, and OpenAI connects users with comprehensive data on professors. I'll dive deeper into the stack and how that works a little bit later in this presentation. This is what the website looks like. The purpose and goal was to allow students to make their schedule easier and find teachers that they mesh with easier. Overview of the platform. AI Rate My Professor utilizes a user-friendly interface that allows students to inquire about specific professors. It efficiently matches queries with a vast vector database, delivering accurate and relevant information quickly. So this is my Jupyter notebook, and it's just an example of what the data within my vector database looks like. So there's the values, which is the embeddings, the ID, which is the professor's name, and then the metadata that consists of the reviews, subject, stars, and it's upserted into my index called Sean with the namespace of NS1. This gets expanded later. I will show you that in further slides. So the tech stack I used was OpenAI, Jupyter Notebook, NextJS, Tailwind, and Material UI. Web scraping. We were able to web scrape Rate My Professor by using specific HTML tags and added it to our vector database after cleaning and organizing the data. So as you can see here, the professor name is scraped by a div with the class name of name, title, name, and that information. So an example of us cleaning the data is subject. We didn't want department in there. We just wanted, like, for example, if it was biology, it would come back as biology department. So we just replaced it with quotes and then trimmed off. So we would just say biology. For classes, we didn't want repeat classes, so we created a set. And then we just trimmed off the text, and then we converted it to an array and then joined it so we would get a string again. And this is the new information that's in the metadata, so stars, subject, review, school, classes. User queries. So users can interact with the AI to ask detailed questions about specific professors utilizing an intuitive interface. Users can either speak or type their question. The AI processes these inquiries in real time, ensuring rapid responses for enhanced user satisfaction. So I'll dive into the speech to text a little bit later, but as you can see here, we're basically fetching from the API endpoint, which is OpenAI, and we're feeding it the content and the subject extracted. So if there's a subject mentioned within the message, so let's say computer science, the subject will be compared to an array of subjects that I made, and if it's included in there, then we would just send to OpenAI to search the vector database for a specific subject as well. So we used Pinecone as our vector database. The platform employs a sophisticated vector database that categorizes and retrieves professor information efficiently. This enhances the AI's ability to provide precise and relevant responses to user inquiries. So that's basically just saying that we used RAG in order to specify how OpenAI is going to respond. Speech to text. So we used the built-in API that is within the window. So speech recognition, that's the API that is provided on most other browsers. WebKit speech recognition is the API that is used for Safari. So we set continuous to false. So that basically means that the speech recognition will stop automatically when user pauses. And then the interim results, that basically we set it to false because we just want the full result to be returned and not just like chunks of it. And then we just set the message, and as I showed in the former slides, the message is being handled, is being sent to OpenAI. We set listening to false. That's mainly for UI, UX. It basically determines what the microphone is going to look like. our advanced query. So users can enter a field, which is a subject, a school, or a course number, and the amount of professors that they want back. And then we just send that to OpenAI. Yeah, and that's the general overview of my project. So let's get into what it looks like and how it works. So AI rate my professor, little Hubert Farnsworth there. So let's test out the speech to text first. Hi, I'm a computer science major at Queens College. Can you please provide a teacher that takes a hands-on approach? And then as you can see the text here, can you please provide a teacher that takes and let's see how that turns out. Okay, so we're provided with two professors, Munji Lee and Michael Freed, both computer science teachers. So let's look into Michael Freed a little bit more. What classes does Michael Freed teach? And I'll give you a list of the classes he teaches. What is his grading policy? And I'll give you information about his grading policy. He gets 4 homework assignments. There's a midterm. There's quizzes. He grades fast. Curves at the end of the semester. Yeah, so that's all the information. And if you're interested, you can add them to your schedule. And then this is our advanced query. So let's say biology, because that was my major. And I went to Queens College, so most of the data is based off Queens College. Let's get 2 professors. And we get 2 professors, John Waldman and David Lochte, which are both professors at Queens College. Okay, and now I'll show you how we can add to the database. So let's go to rate my professor. Let's take this professor right here. And they teach at NYIT. So let's go back. And Tao Zhang was successfully added to our vector database. Thank you for tuning in to my presentation, and have a wonderful day.